Um, well, if you're here, thank you for being here on time. I've got on the screen that we're going to be again working in AutoCAD today. I'm going to be using this particular drawing from your book and layout 1. DWG, so you could upload that if you want to work alongside or just even take a look at it and practice later. I also posted that there is a new survey in this week's module, and it's just about your AutoCAD, your usage of AutoCAD, just to give me some feedback. So while we are again waiting for the rest of the class to arrive, this would be a good time to complete that. Any questions anyone has? This is also a good time to ask me some questions if you have anything on your mind that you want to discuss while we're waiting. And you can just speak up, because when I'm sharing my screen, I'm not able to really see the grid.
I do have one.
Go for it.
This is more towards about the final project, about like, if you could just give us like an idea of how to go about the drawings. I'm a little confused as to like how you would want how to do the drawings. Like,
yeah, so that's what this whole class is about, actually.
Okay.
So that's the topic of today. And it says it right on the screen here, working drawings, is how to create that package that you need to submit. Is that what your question is?
Yep.
Perfect. We're going to go through that. I'm going to show you an example. And I'm going to show you how we're going to convert your drawings and model space into printable format for your final project. So perfect. Great. Okay, it looks like we've got majority of the class here. So we will go ahead and get started. On the screen, you see that I'd like you to start up AutoCAD. We're looking at one particular file today that we'll be working with. And as I mentioned earlier, there is a survey in this week's module about your AutoCAD usage. And if you would just complete that by Sunday, that'd be great. You're certainly welcome to do it during the class today, during our free time if you want as well. Okay, so stop share there. Before I get started on that, I want to go over the homework from last week, with the one caveat that I have not graded any of your submissions. So I'm going to speak in general terms. I'm not going to be able to pinpoint things that I've seen in your homework assignments as I discuss these problems. And actually, I just realized that I don't have one of the problems with me on the screen. No worries. Okay, so let's start with that. And we'll go from there. And I apologize, I haven't created any of the assignments. So let me see here. Let's see if I share that. Oh, I do have it on the screen. Okay, good. Okay, this was problem 1 right here. Let me see. Okay, hold on a second. I need to close my PowerPoint in order to share. Okay. All right, share screen. Let's see if this works this time. Can you see my screen?
Yep.
Okay, great. So this was the first homework assignment. Or the first problem on the homework. What I want to point out is that note precision is no decimal points here. And what else? The extension line here is not interfering with any other extension lines here. This should have been fixed, so let's fix it now. So one thing about our center mark, which we want to always maintain, is a space between the extension line and the edge of the object. So I don't have enough yet. I'm going to keep going. Let's see. Yep, that creates that. So I'll be looking for that when I grade the assignment. So there's a bit of cleanup you have to do. The radius value here is easily put like this with an arrowhead, which works. Note for this particular arc, only dimension you need is for the placement of it in the center, so the Y dimension, because it's all along the edge here, and then the radial value gives you the rest of that. That also gives you the length of this particular line once that's created, and the length of this particular line. So those are not needed. Okay. This one I asked you to do baseline dimensions on, and you can see what baseline dimensions look like. Okay, and the key here is using our center mark as an extension line for each of those that the dimension goes to. So we want to extend that center mark out. We want to connect the center marks here so that this baseline dimension over here goes all the way through, maintaining the gap around that hashtag. And then this side can be done in baseline dimensioning as well. Some of you may have extended this over to here as a 30, or if it was too much, getting too muddled because you have an extension line going through the object, it's okay to put one over here. I think what most people miss on this problem is the width of the hump here. And so you can either give the overall width as 30 or the half width as 15. Note how the holes have been dimensioned and the fillets and rounds have been dimensioned as well on this using using a leader line and some text so that we can just dimension one of them and then apply it to all. Any questions on that? Okay, and then this problem is just simply a matter of adding ordinate dimensions, connecting those dimensions to the center line here, and then making sure we also dimensioned our holes. Same thing, 6 times diameter 20 means that all of these have the same exact diameter on the holes. And then you needed the 0, 0 here. And the overall dimensions can be ordinate style as well. One thing I want to point out, holes, as a reminder, have a diameter, and fillets and rounds have a radius. So in all of these, you see all the holes have a diameter. You see that when it's not a perfect hole, a circular hole, it has a radius. It's considered a round. Okay, and then the last one is this one right here, which I asked you to redraw and put in dimensions. And you can see that this one actually doesn't need a lot of dimensions on it because it's a symmetrical object. And we should add the symmetry symbol right here. Oops, I'm showing my other class 3D modeling. We should add a symmetry symbol right here so that that is perfectly clear. And a symmetry symbol is basically 2 lines, and I should center them, but it's 2 lines that are like this on both sides of the center mark here. So the key dimensions here, and this was something I added to show someone how to add. The key dimensions here are that you have all these holes, they are equally distributed. So you can actually create a one dimension for all of them, which says, okay, space them out 16.4 degrees. This is the one dimension that AutoCAD is generating for you because you can recognize this as an array. So you didn't have to place these yourself at where they belonged. So that was the one where I said 1 decimal point would be appropriate. The rest of these are no decimal points. That was true all throughout all of our problems because we were counting grid spaces. And then you have the inner arc, you have the guideline, you have the outer arc. You can see those are the radial dimensions shown here. You have some fillets in the corner here, which are given right here. There is this one dimension above the center line here that it's 10 millimeters above, and then each of the holes is diameter 10. So that was all that was required to fully dimension this object. Again, I have not been able to grade your assignments to see what everybody was doing, but I will look at that. Are there any questions on that?
I have one question.
Yeah, go for it.
So because the circles, the small inner ones, because they're part of an array that's along that guideline, do they not need center marks inside them?
Well, I have this guideline. Yes, they should also have center marks in there. Yeah. And they
Thank
could
you.
be rotated as well. So if we had created the first one and put the center mark in there, it would have automatically created center marks throughout. And then we would have cleaned them up to remove the horizontal pieces of it where the guideline was. So yes, you should have center marks. Thank you for correcting that. Okay. Other questions? So I will fix that too in here. No, it doesn't want one. Okay. Anyways, so I will hopefully grade those soon. Yeah, okay. So that's the homework. So then this week, I want to say is that there is no official homework assignment for the AutoCAD portion of the class. However, I understand that you are working on your set of drawings for your final project. Is that correct?
Yes.
Okay. And for that, are you, so have you guys all completed building your final project or designing it?
Designing it, yes. And then some of us have, I don't know about last on Monday that we talked about it. Some of us have already started working on the actual thing.
Okay, so so when you say you've designed it, did you design it in AutoCAD or did you design it on paper, have a rough sketch?
Paper, and then also some parts on AutoCAD.
Okay, great. So what I'm going to show you today is how to format those drawings in AutoCAD. And I see that a couple Mondays ago, Joanne went over working drawings. So what working drawings actually look like, and hopefully she went over a drawing package. So can you tell me if she went over a drawing package? Assembly drawings. Did she do a drawing package?
I don't believe so, no.
Okay, thank you. So let's start with what consists of a drawing package. Let me just pull that up. Okay. And I'll share my screen. So a drawing package is basically a set of drawings that you put together. Where's my, there we go, okay. Can you guys see my screen? Because the green window is not on it.
The assembly drawing, yes.
Do you see the whole thing or part of it?
Part of it.
Part of
Part
it.
of it. Okay, let me try again. Okay. You see it now?
Yes. Yes.
Okay, great. Okay, so I know that she showed you assembly drawings. The first page of any drawing package is that assembly drawing. And I assume she's told you how to format that with the leader lines, the part numbers and the circles and all of that. What comes behind it is called sub-assemblies, which are assemblies of like smaller portions of the object, and detail drawings and the parts list. The detail drawing is a drawing of an individual item in the assembly, which is all dimension. And I'm sure she told you that assembly drawings do not have dimensions on them except in rare instances. Is this all true? Yes, no?
Yeah.
Okay.
Yes, mostly. Yeah, pretty much.
Okay. So here is an assembly drawing as an example. Okay, and Here is an L bracket with this little block on it. It has 5 different pieces, parts to it, some of which have been duplicated. So for example, number 4 is a washer, and it is used 3 times. So you can see every time it's used, it's labeled, right? So this is what we want to do with our final project. We want to create an assembly drawing of how it looks overall, how it comes together with all the different parts. And then we want to do individual drawings of the pieces, and those have dimensions on it. So for in this example, this L block here and this little block here, we have detailed drawings. Now, washer, the bolts, and the nut, not, because those are standard parts. So we could just list them as standard parts. Someone could go to a hardware store and buy it, and you wouldn't need a drawing for it if it already exists in the mainstream. Only the part that's being manufactured by somebody you're giving the drawing to would need a detailed drawing. You'll see that there are no dimensions on the assembly drawing. However, there is this reference dimension here that when this is assembled, width of this should be around 225. So not 250. You've done something wrong. You haven't tightened that bolt enough if that's the case, okay? So that's what that one indicative dimension is telling you. There are also no hidden lines in the assembly drawing. We reserve all of our dimensions and hidden lines and everything for our detail drawings, which are those 3 orthographic views that we put on a drawing. The other thing you'll note is there's a border, there's a title block, there is a sign-off checklist, and there's a tolerance block. Don't think Joanne has asked you to put the sign-off checklist here, so I'm not going to talk about it. And I have given you tolerance block, I believe. So you should have this. You should have the tolerance block to add to your drawings. You have your title block to add to the drawing. She probably discussed revisions, so I'm not going to look at that. Okay, so then those are the rules, which you've probably already discussed. These are those various areas that I just noted. Here is an area where you can put any notes regarding the assembly. You can put the parts list on the assembly drawing, the front sheet of that drawing package, or you can put it on the bottom sheet. Either way works. Okay, so you'll see some assembly drawings that have the part list here, and I'll show you that. Others that don't. All right, so that's that. This is a border. This is a typical border we would use, which has numbers across the top, letters down the side. In this week's module, I have provided you with a few border templates. They're blocks. I will show you how to insert them in a moment. That's what you want to do first, is insert your border, insert your title block, insert your tolerance block into your printable area, and then you'll start to insert the images that you'll be printing on that. Okay, we don't need to talk about the title block. You know all that. How do you name it? Name a drawing. So rule is you give it a noun, you talk about it, and then you might have more that you want to say about it. In normal sentence language, it's kind of like taking the adjectives that precede the noun and putting them behind. So if I was talking about the shaft, I might, written language, spoken language, say, I have a high-speed left-handed shaft, left-hand rotating shaft. Instead, we name our drawings, we put it noun, shaft, comma, high speed, comma, left hand. So what is this? Ultimately, it's a shaft. This is something about the operation of it. Okay, so that's how we name our objects. Now, the other thing in your drawings is you're going to want to have in your title block, in addition to the drawing title, which we talked about when we said, how do we make a title block? You're going to want to also include the part number from the assembly or detail drawing that it associates it with, so that someone looking at the assembly drawing, back up to this one, somebody looking at this says, oh, I want to get an idea of exactly what part number 2 looks like. They would be flipping through the bottom corner here and looking for a little block inside the title block that said part number 2. So kind of just lifting up that corner and then getting to the page that says part number 2. So we want to correlate our pages with our drawings so that it's easy to find the corresponding drawing in the set of pages. Okay. So those are some examples. We're not going to talk about that. Tolerance blocks we talked about, not that. Okay, here's a parts list. So here's a detailed drawing, actually. Let's talk about that. Top page, assembly drawing, possibly some sub-assemblies under it, which are very similar to the overall assembly, except that they're just taking a part of the overall object and showing it in assembly. I'll show you that too as well. Detail drawing. This should look very familiar to you. This is a top view. This is a front view with dimensions. This is a 3-hole block. These are geometric tolerances. I'm not sure if Joanne has gone over that, but we won't be going over that. So you can ignore those. But basically, this is, you know, what you're familiar with. This is one piece of an overall item. You can see some notes have been added here about the finish of it. Parts list, you've gone over this. You should probably recognize that this is a parts list. This is actually the parts list for that assembly drawing that I showed you. It has 6 parts. It has 1 extra screw here. You can see the description is given with noun, comma, modifier, and how many of those are included, which is important. It's also sometimes called a bill of materials. You'll see that interchangeably. So some people may label it as a parts list, and other people may label it as a bill of materials. Here's an assembly drawing with bill of materials or parts list attached to it. Again, every part in that assembly has a number, a circle with a leader line, indicating, you know, directly pointing at it. In this case, there are 2 of these. These happen to be the plane washer, which is listed in your parts list, so you can figure out what it is. It says that there's 2. And then for each of these, there would be a detailed drawing. So behind this, the first detailed drawing would probably be for part number 1, lever. The title of the drawing would be lever, comma, part 1, or in a different block, you might have part number and put 1 in there. But that number part has to come into the title block of the detailed drawing. And in that, you would have the front, top, and right views of this lever with all of the dimensions. Okay, and that would be true of all 4 of these first 4 pieces. The washer is a standard piece, so you don't need a detailed drawing for it. It's number 6, a square nut. If it's a standard square nut, you wouldn't need a detailed drawing. If it's something that you need manufactured, you can't buy off the shelf, then you would need a detailed drawing showing the size specifications of what needs to be manufactured. Okay. In this case, I'm guessing by the fact that these specifications of the size of these objects have been given, not a part number, means that these 2 are standard parts. These 2 are the ones that this Boston University is producing. It's Boston University part number 131, right? That's how they've labeled it. Okay. This is an example of an assembly drawing with notes, parts list, title block, sign off block. Tolerance block is missing because this is an assembly drawing and there are no tolerances on something that has no dimensions. In this case, it actually does have some dimensions, and I'll talk about that in a minute. What I want you to see here is here's your isometric, here's your front view, top view, side view, and section, because so many of the parts are internal to the object that they can't be seen in any of the other views without creating a section view. Each one of them is labeled, as we've discussed, each part a number in a circle with a leader line. And some of those are actually on the isometric. I'm not sure that that's the best place for them. I think I would have put them on the top and front view rather than on the isometric here. Okay, so why are there dimensions here? So some of these I can understand, some I don't. This is something I downloaded off the internet, so you know somebody has done this. Let's say you put this whole thing together and its width of it total cannot exceed the number that's listed here. Then you want to have that. It should be a reference dimension. Reference means in parentheses, so that someone putting this together says they wanted to measure it with a set of calipers and they say, oh, I'm close to this. That's I'm supposed to be at. And if they're not close to it, then they need to tighten some pieces up. So this overall dimension here makes sense to me. Because some of these other, this one here may also make sense in the same context, and the placement of this particular hole in reference to the slot makes some sense. overall width over here, not so much. That should be given in the detail drawing of that particular piece, which is number 16, which is the gear. So no reason to put that here. This is an assembly drawing. Okay. So that's one example. And this is showing you how you can add some drawing notes. Why would you add drawing notes? Well, something about the assembly, like somewhere here it says the word welding. My eyes are not doing so well. If there's some welding required, you might put a note there. If you have some sort of way that it needs to be put together, like put it in order, like start with number 5 and then attach number 1 to it, something like that. That could be something you put in a note as well. Anything about putting it together. And I'll show you another example of that. It might be more applicable to what you're doing. Okay, another, here's a detail drawing, okay? And now, so these are notes to the overall, so it says here, unless otherwise specified. So unless otherwise specified, okay, there's nothing else otherwise specified here. Here, this note here in the little triangle with the number in it, specific to this diameter here, not to the overall piece, just to that one part of it. In that case, it is put in an up triangle like you see here with a number, and that is included in our notes section. So if you look here, this diameter of whatever it's tolerance diameter has a note. Drill this diameter ream onto that hole as well. Okay, so you could have put that in the dimension itself, that this is a ream, needing a ream on it. If not, you could put it as a note as well. And then this is another note that applies to the whole overall object. Big sharp edges to this maximum. I'm not really sure what that means, but that's just an example. This is also showing a section view to show the internal features, but in this case, the front view is a section view. This is always allowable. This would have been the title block here. So now let's look at an example of a project that someone has done. Let's see. So that you can see kind of a project drawing package. So this is a class that I taught at a different college. And in that class, we used to have the project of building a popsicle stick bridge. And we would test it. So it was something that we had to do in person. For that project, much like your project in this class, they had to produce a set of drawings. And these drawings are by no means perfect. We can point out lots of things wrong with them. However, it does show an overall package. And that's what I kind of want to show you. So here is top drawing. And this is an attempt to be an assembly drawing. At this point, when this was created, they didn't know how to create an isometric view. So I'll show you the isometric view too. I do want you to take note. This is a popsicle stick bridge, and it basically consists of 4 sub-assemblies. The overall bridge is 4 sub-assemblies. 2 of the sides, 1 of the plank base, and 1 of this top support. So it goes from here to here. These 2 edges come together. They have labeled them incorrectly. So this should be 2 times 1 circle. Okay, so that's subassembly 1. Subassembly 2 would be in a circle. And subassembly 3, there should be a circle here. But we have put a note here, glue at all intersections and clamp together. It's glued till it dries. So it is indicating that, going to glue this piece to this piece, this piece to this piece, and this piece across the top. And we're going to use a clamp to hold that together. Okay. So behind this, what I would expect to see is 3 sub-assembly drawings, 1 for each one of these that you see here, and then detail drawings for each one of the pieces that went into those sub-assembly. So that's what we're going to look at. And you'll note here, title block and tolerance block. All right. This is after we learned how to do an isometric view. They did this. And then obviously missing is the flow arrow right here that shows how it comes together. So this piece where it actually attaches onto this bridge here, and then this piece comes down between these two top. This is how it would really look in assembly. So that really shows kind of it coming together in its correct positions. Okay, so here's subassembly one assembly side, one assembly side. That's what they called it. Okay. And you can see here, there's all these different kinds of popsicle sticks that have come together. They have a center line here and have indicated these pieces are symmetric, which means all the ones here are the same as what's here. They have a note, glue, and clamp to get it to stick. What else? So what's missing? Okay. These are, this is part 1A here. Okay, we don't know what part 1A is made of. So that means that we need yet another subassembly to show us how 1A is made, right? How is 1B made? How is 1C made? So every time you see, let me just indicate to you that every time you see a P, that's an individual piece that they're going to give a detail for. And these are further subassemblies of these individual pieces that are coming together. And I just know that because I've examined this, that's their naming convention. So all of this should have been in circles so that we would better understand what's being pointed to. I think the next drawing is of 1A, right? So 1A is a beam right here, this beam right here. And here you go. Here's how the beam comes together. It's a subassembly. And you can see there's multiple layers of these pieces, so this is, again, I told you they're not perfect, but we needed a number of P6. So I could count 1, 2, 3, but this should really say 3 times P6 right here. And this should say whatever, 3 times P7, right? And go back and forth. All of these, they should all say that. Got their note, right side view, top view. Okay, so we kind of start to see how these are coming together. This is part 6, this is part 7, and how they come together. One piece of information they're missing is the overlap distance right here. And that could have been a note placed in a triangle here, note number 1, all of those sections here, a little triangle with the same note 1, because it looks like it's symmetric. And down in here, note 1 have said overlap by, I'm making this up, 1 centimeter. Idea here is that I should be able to build this based on the drawings provided. And that's the one piece of information that's missing. In addition to that, the overall length here as a reference would be very useful so that when I rebuild it and I measure it, I'm pretty close. If I get the exact pieces of the parts, the exact sizes of the parts, right, and overlap them exactly as indicated here, then the overall length should be round about what they achieved. But as a reference, it would be nice to have an overall length, and we definitely need the overlap distance here in order to recreate it. Otherwise, we can't. So this is a subassembly. Here's a part. Here's one of the parts. This is part P2. This is a popsicle stick. So they started with just, all of this is popsicle sticks. They started with the standard popsicle sticks and modified it. So in this case, they modified it by cutting an angle at one end and cutting off the rounded edge here. So this is my notation here. I cannot reproduce this part without knowing what the angle is here. This is a missing dimension on this particular drawing that's necessary. And then there would be edge line here as well. In the top view, if you rotated this up, and this is the side view. This is a detailed drawing of one of the pieces of the bridge. One plank that went into one subassembly that went into the overall assembly of the bridge. Okay, here's another one. In this case, it looks like they may have cut the popsicle stick in half. This is done correctly. This is part P6 for them. Another one, a little bit different size. And then this is, I guess, their parts list that they put at the end. Bill of materials is what they called it. It's not perfect, okay? They've said part 1 is popsicle stick. Well, here, there's no way to relate part P9 to part 1 popsicle stick here. So they needed to have a note here that said, take part 1 popsicle stick and cut to dimensions above. And then it says 300 to 400. It's too vague. You need to have an exact number. How many parts are in your final assembly? Looks like they used Elmer's glue, and they have already talked about the clamps. The problem with this is that you don't know what kind of clamps. There are all sorts of clamps out there. So they needed to be more specific about were all 10 identical, or there different kinds of clamps. All of those need to be listed in your parts list and then indicated in your detail and subassembly drawings. This is not related to this project. Sorry, this particular bridge. This is a different bridge where they have put all the different parts on one sheet of paper. These are all their detailed drawings because it was uniform popsicle stick made that was cut up basically. So this was allowable here. I would have made P1 part 1 whole popsicle stick right up here, and then all of these were modifications of you can see their parts list. It's not perfect. It talks about, what each of them is. It doesn't tell you how many you need. Again, what sort of clamps are used. But this is a good presentation of the notes. So they put in note number 1 on all of them. Note is all of these are this much thick. In doing so, they eliminated the right side view of each of these. And then the top view wasn't really necessary either. So that note helped to clean up the drawings, remove stuff from the drawing that was unnecessary, repetitive. So this is what we're looking for in terms of a set of working drawings. Working drawings is your overall assembly, any sub-assemblies that are necessary, your detailed drawings, and your parts list. So the way it's put together is in the order I just told you, with the assembly on top, sub-assemblies that follow, parts after that, detailed drawings after that of the parts, and then the parts list generally. The way it's read is backwards. So let's say I want to build what one of you is building. In one of my classes, someone's building a bird feeder. I don't know if anybody in this class is. Let's say I wanted to build that bird feeder. Where I would start is in the back. I'd say, okay, what parts do I need? And I'd gather all my parts together based on the list provided. Then I'd go to the next detail drawings and make sure all those parts meet those dimensions that I need. And then I'd go to the subassembly and I'd pull out the parts I need to make those individual littler parts of the final. And then I'd go to the assembly drawing and put it all together. And the idea behind it is that this set of drawings eliminates all need for a verbal or text communication between me and the person that designed it, because it's been made to a set of standards that we all understand. So when you first started this class, you probably talked about engineering graphics, and the concept behind engineering graphics is putting together a set of norms that any engineer can read so that there's no confusion. So we have first angle projection as a symbol we can add to our drawings, which indicates that we are showing the top, the front, and the right side view, third angle projection shows those three, as opposed to first angle projection, which shows a different set of views. So we have established basically a language through these drawings, and the format of those drawings indicate exactly how to recreate anything in them. And that's what you're going to put together. So you've all designed something for your final project, and you're creating a set of drawings that anyone can start at the back with the parts list, or the front if it's on the assembly, gather all their materials, every single thing that's needed. And that includes whatever was used to cut. Because if I don't have what's used to cut, I may not be able to get the precision that you got. If you're using a laser cutter to cut something and I only have a pair of scissors, we're going to not produce the final same product. Okay, so in those parts lists, they also should have indicated what they used to cut those popsicle sticks. So I gather everything together, if not in the parts list, then in a note on the parts list. And then I say, okay, what's the first thing I do? I go to the page in front of the parts list and I say, okay, I need to manufacture this part. And then I go to the next one and I need to make this part. And I need to go to the next one and make that part, etc. As I've already talked about, working our way through. So at the end, when you have completed your set of drawings, you need to put your object aside and not look at it. And you need to look at your drawings and say, could I recreate what I have actually created just from this set of drawings? And if there's information missing, you need to add it on so that anyone can do that. That's the whole point of that. Does that make sense? Are there any questions?
I have a question.
Go for it.
So for some of the materials we might use, for example, in the bridge that you showed earlier, it said Elmer's glue. So if Elmer's is a brand and we want it to be more generic of like some type of glue, would we have to be like super precise, or could we just say the brand name of some kind of thing we're using?
Okay, so all of you, I'm assuming, are going to be using different materials for adhesives. Is that correct? For your projects?
I think so.
Yeah, you should specify what you use, not what's acceptable. Or, you
Okay.
know, so if Elmer's glue is acceptable as well as rubber cement, I would, in my parts list, indicate what I use, and then as a note, say, in the absence of Elmer's glue, feel free to use rubber cement.
Okay, sounds
So
good.
it's a note on that part, but in your parts list, you're listing what you used.
Okay, so I'll put down exactly what I use, but I could
Yes.
also put down any substitute for this works so long as it's XYZ.
Yeah, like what properties are needed, right? Does it need to be waterproof? I don't know, you know, does it need to be able to, like wood glue is a little bit different than just your non-toxic children's Elmer's glue, right? Does it need to be able to connect wood? In this case, Elmer's glue does connect popsicle sticks, but it wouldn't work for all applications. So, yeah.
Thank you.
Yep. Other questions? Okay. Okay, well, if questions come up, feel free to, shout out. Let's now look at AutoCAD. Let's talk about your drawings that you're doing and putting them on a working drawing. Okay. So, or into the correct format, I should say. So I'm going to share. Go ahead.
I have a question. So I have like some drawings done, but could maybe before we talked about like the layout, because that's kind of like the final project or the final product, could we talk about like, I don't know how to scale my drawings so that they would, is that would be done in the layout, right? Because I watched.
So that's what I'm going to talk about. Yeah.
What about annotating, and what about
yeah. So we're going to talk about all of that in this example.
Okay.
Is that good?
Yeah, definitely. That's everything that I need.
Okay, so let's just first talk about scaling. You guys are drawing in model space, and the rule of thumb is that in model space, you should draw everything 1-to-1. Okay, now that is probably not true if you're building a large table, that you're not drawing it 1-to-1, but then you need to make note of your scale. It's really important because on the final drawing, your scale might need to be on your printable page. Your scale might need to be updated in your title block if it's gotten smaller than what you drew it to. So you have to keep track of your scale, is what I'm trying to say. Does that make sense? So let's say you were making a table that's I don't know, 6 feet long. Okay. And you're not going to draw in model space 6 feet. I mean, you could, but you're probably not going to. Instead, you're probably going to draw it at 6 inches. So now you've reduced it by 1/12, right? So your scale is 1/12. When you go over to put it into print, your scale may further reduce, in which case you need to make note of that. It's probably unlikely that it's going to print at 1/6 when you put all your views in. and then you'll have to update your title block, and I'll show you where you can find all that information. All right, so I was sharing my screen. I was going here, share. Okay, here's two views of something, some sort of gasket. And let me just double check. I think it's dimensioned properly enough. This is your end layout one that was a part of your book. Okay. And so you've created your two views and now you want to print it. So down here, if you'll note, we're in model space. That's where you draw. And as much as possible, we draw one-to-one model space. Where we print is layout view. And if I just click over to layout view, this is what you will see in layout view. And what it's done is created a window called a viewport of your model space. And that automatically pops up in layout one. Okay. Generally, when we come over here, we want to delete the view that's there because we want to create our own views. So this is our blank template of a page. You could go to your page setup manager and make sure that this is 8.5 by 11. Select the right printer, which will actually create the right size paper here. So you should do that over here. Just go to print, which is the print utilities. Yeah. Okay. So then you set up, which is your printer and all of that, and it will create the right one. Now I don't have my printer here. Oh, maybe this is mine. Okay. This is my printer. So it knows it's 8.5 by 11. It's in landscape mode. I could change it to portrait mode. What to print is the layout. Okay. Which is the whole page here. So that's what we want to do. Don't want to scale here, fit to paper. Again, we need to pay attention to our scale. So we're going to not scale here. And then the key here is that this preview button. So after you've made some changes here, it's always good to go and preview what it looks like. Nothing's there, obviously, because I have nothing on the page. And I hit escape to get out of that. And I just hit apply to layout and hit OK. So it just applied that printer setting, what decided to print to. It just applied that printer setting to that to my layout. So this is the 8.5 by 11 page. So the first thing I said is that, okay, you've got your drawing here that's complete of your two views, and you're going to need to create an isometric of that as well, okay? And next week's class module videos goes over how to create an isometric drawing. And it's basically just a rotation of our cursor right here. So typically print top, front, and right view. We want to create those in layout. And then we put our isometric up here. So, but first we want to add a border and a title block. So I've provided you with some borders. This is one of them. So here's my border, right? I'm bringing it in. Let's see if I can move that out of the way of the words. All right, there we go. And it's not scaled perfectly, so I'll let you scale it, but let's just drop it in right there. All right. We've got our numbers, we've got our letters, and it needs to move in a little bit so that it's in the printable space. And this is important for you guys because I think you're going to print and provide a hard copy, right? You're doing electronic.
She said she wanted it as a PDF form.
PDF. Okay.
Yeah.
So that's electronic. That's electronic.
Yeah.
Okay.
Yeah.
Yeah. So even in PDF, sometimes you have to scale this. So you'll need to take the border and scale it. That gives you practice in scaling. It's just a minor, 0.98 scale or something to get it into the printable space. But you insert your border. Then insert your title block. We've created a title block together. So you guys know this. And I mentioned earlier that see my insertion base point is at the bottom right. I'm going to insert that right up against the border there. Let's see if I can get it. I wish I was using my object snaps, but I'm not. Okay, there we go. And then this is with attributes, so it's gonna let me input all that. I'm not gonna worry about it right now. You can always double click it, get back to the attributes. So this is where we start, right? This is our drawing format. We could also insert our tolerance block right next to this. All right. And those are for tolerances we don't specify directly in the dimensions. So now what we want to do is insert our what's called our viewports. Okay. And well, this is in the way here. Okay. Let's go to layout. There we go. All right. So if you go to the layout tab, top, it gives you the options of different kinds of viewports. So you can do a rectangular one, you can do a polygon one, you can do an object one, or you can just insert a view that you select from your model space. So if I hit insert view, I go over here, it says, what view do you want to select? Well, I only want to insert. I only want to insert the top view. Go grab that, hit enter. And then it allows me to put the top view perhaps right here. Okay. Or I could have inserted a rectangular box. And what it will bring over in the rectangular box is everything in the model space. So insert view, I was able to select what I want to bring over. Insert one of these predefined shapes brings over everything in that shape. You don't have to show everything in the shape because you can zoom in and zoom out. This is where paying attention to your scale really matters. You'll also notice that in this case, dimensions are smaller here. These are using annotated dimensions where they're scaling down with the size of my viewport. So that is the concept behind annotative dimensions, is that they will scale in size down, maintain their correct height for the size of the object when you put them in viewports. Anytime you have a viewport, you can select it and delete it, so you can get rid of it.
I have a question.
Yep.
When I inserted a viewport, the grid showed up behind my image.
Yeah, the grid will not print, but it does show up. I don't know why mine isn't showing. Oh, because it's off. My grid must be off in model space. So when my grid is on, it will show up here.
Okay.
Yeah, but it won't print. So no need to worry about turning that on and off. Okay. I guess this one, it just was off. No big deal.
Okay.
What else? Oh, right. Okay. So those of you on a Mac, if you don't see this layout tab, you may need to type in viewports like this to get a menu that allows you to put in viewports. And this one is particularly an interesting menu because it allows you to break up the screen automatically. So this will create two equal size viewports side by side. This will create two viewports top and bottom, right? One we normally work in is this one. We have our top view, our front view, our right side view, and in this corner we put in our isometric. So let's do the for equal and hit OK. And it always wants us to start. So let me go. Let me see if, oh yeah, it won't let me click over there. I think you have to set up your snaps before you come over here to use them because my O snaps are off. I don't have that option. Here we go. All right, so there's 4 equal viewports. This is one way of doing this. Okay, and then once you've established a viewport, you can double click in it, and you can do whatever you want in that viewport. So you can zoom it, zoom out. Let's see, let's put it here. Okay, so this was 1-to-1, drawn 1-to-1 in model space. Note now its scale is 0.85, whatever, 6, blah, 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 blah. So in my title block for scale, I would have to put a reduction on that. If I want to, I don't see anything else that would really work. This is going to be too small, I think. Well, there we go. Okay, so this is 1/2. So on your drawings, if you did 1/6, and then you come to viewport and you do 1/2, what's your overall scale? I'm sorry, if you draw 1/12 of the true size, and then you come to viewports and you scale it down 1 to 2, what's your overall size?
1 to 24.
1 to 24. Thank you. Yes. So you need to put that in your title block. Okay, that's your overall size now, right? You're
But if
drawing.
we, sorry, if we drew 1 to 1, then whatever the scale is in our layout is what our scale is, correct?
Correct. And please note that in order for that to be true in your title block, each one of these has to be set to that scale. So if I double clicked here, you can see I'm on a different scale here, right?
So they
I
each
wanna-
have to be the same scale.
Yeah, in order for you to put it in the title block overall, you need to put it in the same scale exactly. Okay.
And could you show how to change the scale one more time?
Yeah, of
You
course.
double click.
So you first double click in the block you want to be in. Okay, so I'm in this block.
Okay.
And then you go down here to this arrow that
Okay.
gives you all of those. Okay.
Okay.
Note that you probably want each window to be the same scale because otherwise your views aren't going to align properly, right? So the only way the edges of this meet with the edges of this is if it's the same scale. So we kind of need to have the same scale anyways. This viewport seems not useful since I don't have a right side view. Oops. So you can get rid of it. You should be able to delete it, but now I've gotten stuck in some command. Hold on a second. Let's see if I can click some. Okay, click here, click here. I want to click on the border. You should be able to delete it. It's not deleting. Let's see if I can delete this one. Word deletable. Oh, there we go. Okay, so I got it finally, and I can delete it. Did you see that? I had to click on it multiple times to make it blue, and I can delete it. That. Okay. So, and then actually now I have more space, so maybe I could enlarge these, right? And your isometric does not need to be to scale. Just, often we don't have our isometric to the same scale as everything else. So it's just the drawings that you really need, actual drawings that you need to be really particular about the scale for. Okay, now the other thing you'll note, I'm just playing around with my reports now, just to make them a little bigger. The other thing you'll note is that for this class, you're going to be doing dimensioning in model space and then bringing that over. Oops, what happened? Okay, I want to escape. I'm not able to escape. There we go. So you're going to be dimensioning in model space and then just bringing over that view. Anything you do here, let me show you something else though. Any changes you make in layout view, let's go here, will change in model space. So let's take that line and say I delete it. It deleted from both views. And if you go to model space, that line is gone too. So you want to try be very careful in your views so that you don't accidentally make a change that you don't want. All right, so this is what, 1/3? Let's try 1/4. Oh, it's too small to make it bigger. Let's try 2 to 1. No, too big.
Then
Right.
I have a question for that. If I have 4 objects drawn in model space, and then I do that 4 quadrants in layout, and now I have my 4 objects in each quadrant, but I want to move it so that only one of those objects is visible in each quadrant, but I can't delete the other ones because that'll delete in all of them.
That's right. So
How do
that's why I've been zooming in and out and moving my page. I don't know if you noticed, but I double click in here, right? Look, the 2 objects are there. I zoom in.
That doesn't change the scale.
Yeah, it is changing the scale. This is what you have to pay attention to is the scale. It's totally changing.
Okay.
That's why I pointed that out, is you have to pay attention to what your final scale is and put that scale in your title block. Multiplied by whatever. If you drew 1 to 1 in model, then your final scale is whatever is listed here.
Okay.
Right? And if not, you need to reduce it by whatever you drew in model.
So
as
then I
well.
have to move them farther apart in model space if I
It
can.
would help, yes, it would help to move them farther apart in model space. Yes, that's a very good point. So that they're not so close together, definitely.
Okay.
Now, let's say you're working over here and you're really happy with these two views and you don't want anything to change. Note down here, there's a lock key. So if I lock this view here, I don't want to ever change it. I can't accidentally double click in it and change anything accidentally. And I can go here and lock this too. And now I can't change anything. I can't double click there. I can't do anything. Okay. If I want to change anything, I can simply unlock it and it becomes available to me. This might be good, especially when you're trying to get all the 4 views together, is if you're happy with one, lock it so that you don't accidentally change anything in it. Not to say, like, look at this one's locked, this one isn't. Let's delete this. Okay. Oh, it didn't change here, which is great. Let's go back to model space. It didn't change. Oh, actually, sorry. It did. Sorry, it didn't change because these lines are not associated with it. Sorry. There isn't anything I could delete here that would update here, I guess, because they're not associated with each other. But it did change in model space. If I deleted something here and it was if I deleted something here, it was associated with a view here, actually would change that because it's making that change over here. It's just not changing any of the settings for your viewport you've created. Okay. Now let's look at print preview really quick just to see what this looks like. As I mentioned that you should visit print preview so you can see what your final drawing is looking like. Okay. So this is what it looks like. You can see my borders are cut off. I need to move them in. I've got viewport line over here. Both of these viewports has its boundary lines on it. And maybe I don't want to show all that. Okay. So this is a really good tool to see what our final drawing is going to look like. Now, you guys have learned about layers. So if you want to get rid of these borders, all you have to do is put the viewport on a layer that you've decided is not going to be plotted. All of these, I have to create a new layer. So create a new layer, and there's a naming convention that something that's not going to be plotted in ANSI, but create a new layer, and I can just call it the no print layer. And I'm going to make that not printable. So I can still see the edges, but not make them printable. So what else? I just want to close out of this. So now I can move this and this. Let's see if I can get them both. I can put them on the no print layer. Put them on the no print layer. Okay. Let's put this one on the no print layer. Make sure that I got them both. Okay, they're both on the no print layer. Now let's go to print preview. And those borders should be, oh, they're still there. Should have been gone because I put them on the no print layer. Okay, cancel. What did I do wrong? No plotting. Let's double check. It should be plot. No. Perfect. What's this one? Oh yeah. Viewport. This is visible viewport present. So these viewport ones are all about working with viewports here. It's not locked. Huh. Okay, I'll do it again. Basically, you can move your boundary to this is it. Let's try putting this on the no print layer. And sometimes we sometimes we have to click a couple times on something. Well, let's do that. I moved one to no print like that. Let's do our print preview and see if it worked. Yes. So see how the boundary went away? So I had to double click on that boundary to make it glue to get it over there. And then move it. Everything inside of that remained, okay? So that way you can still work with sizing of this window. And sizing of this window, you can play around with that as much as you want. Now, the other thing that's interesting that you can do is you can create any shape window you want. Why am I not able to create a circle? Something's wrong. Let's do circle diameter. Okay, hold on. We got a model. No, that's there. Right. No, that shouldn't matter. Sorry. I want to put a circle here. It might be because it's not clicked. There we go. Okay. So it's clicked in a window. Here we go. Okay, I want to put a circle here. All right. So you can make any shape you want. And then you can go to layout and you can pick a shape to be your window. So I'm going to select this one. And now you can see that I created a circular layout, circular viewport. I'm trying to double click it, sorry. And then I just wanted to show some tiny piece of this. Let's see. Just perhaps that edge, right? In my circular window, I could it's like a zoom in window, right? On a drawing. So you could do something like that where you create a circle. In this case, in your circle, you may actually want that edge to show of your viewport because it's a circle like that. So you can create different shapes of viewports. You can create different configurations of viewports. I showed you how to do 4 of them. So this is how you're going to create your final drawing. And this is a detail drawing. On top of this, you would need your final assembly. So how this piece fits with the other pieces. And let me think about that in the context of your projects. So if you've drawn your isometric, I would recommend making a copy of it and moving all the pieces apart. And that should become your assembly drawing, showing all those pieces coming together. Does that make sense?
Yes.
Yeah, that makes sense. But I mean, at least I'm not. I didn't know we were supposed to make a drawing of our overall project. I've been doing all the orthographic and isometric views drawings for the detail drawings for each individual piece. But I do not, my only drawing that's going to have every part in the same picture is the assembly drawing.
Right. And the assembly drawing shows all the different little isometrics coming together.
Right. It's just that when I go to do my assembly drawings, how do you do things that are coming in from the back? And they're going to be at different angles than I'm going to be seeing a different side of my isometric. Like I drew my isometric so you see the front, but if like I have things coming that are attaching to the back of my.
You draw leader lines that show them coming into the back. Do you want to share yours?
Well, I haven't really drawn. So I would just draw that part and then draw like so I just have the isometric in my model space, and then I draw say 4 leader lines showing the 4 different places that it's going to go.
Yeah, you draw arrows showing, that's called the flow of the flow arrows. You draw those showing where they're going to go.
And they don't have to be directly like parallel to the part. Like the part doesn't have to be exploding out in line with where it's going to be.
It should, but
I'll share. Hold on. I have to log in on my other. But I do have another question about annotative dimensioning because it asked me, you are creating an annotative object, set the annotation scale to the scale at which the annotation is intended to display. Is that 1:1? if I drew in one to
What
one.
menu are you in when you do that?
I just went into dimensions and then I selected annotative and I hit set current and I hit OK. And then a bubble pops up that says set annotation scale.
Okay, so okay, hold on. Let's share a screen so we're all on the same page here. I'm going to share my screen so that I'm following along and everyone else is too. So do you see my AutoCAD window, everybody?
Yes.
Okay, great. So you went here.
Yes.
You went to annotative, which is totally fine. What I would do is make a copy of it rather than change any baseline values. So that's what I would do first.
Okay.
And then here, I'm going to go to text. And usually our text size is 1/8 of an inch, 0.125. We want it horizontal. This is all fine. Then we're going to go to fit, it's annotative, which means that when you change the size of the drawing, the text will change accordingly, but maintain that size dimension. Primary units, I don't know, something like that. Let me double check. I think that's it. Okay.
Okay.
Arrows, let's make sure our arrows, they're really small too. Oh, they don't look that small. Let's just make them a little bigger. I don't know. Hit OK. All right. And set current, close. And then I'm going to add in a dimension. Okay. So this is speaking to the drawing scale at which it's been made at. And this is what you said. You're like, you got this option and you didn't know what to do, right? Did you make your drawing at 1:1?
Yeah, but now that's not popping up. I don't know. I made a copy of annotative and just followed all the steps you wanted me to do, and that didn't pop up this time.
That's okay. There's another way to get to it. Okay.
Okay.
So here we go. All right, there's that object dimension. Okay, now when we go to layout space, so here we want to turn on add annotative scales. This is the button you want to turn that on to.
Okay.
And I might have had to do that before I added this. Let's see what happened here. Okay, so here, show annotation objects. So here, if I click that on, it's now going to show this is an annotative object. And if I don't click it on, it's not going to show. The other thing about it, though, is on properties menu. Let's go back here to properties. Automatically, let's go into the text. All right, let's see here. Why do I keep going into the text? I just want to be on the full dimension. Okay, just wants to do that. I'm not really sure why. Home, I want the properties palette actually. No, it's not giving that to me. Properties. There we go. Finally got on it. Properties. What does it say here? Your properties. There we go. Okay. So here is that annotative scale. That's what I wanted to show you. And you can get to this and you can add various scales here as needed as well.
Okay. You went
so
properties.
Yeah. So it took me a minute to double click on this to where I get the blue. I didn't want to be in the text. It just kept throwing me into the text. I wanted the whole dimension. I went to properties and I did down arrow here to get this menu. And then here is the annotative scale that you said that wasn't coming up again. Now, the interesting thing about this is you can add your dimensions using different scales. Okay, so you can dimension this side of the object with the 1:1 scale, and you can dimension the other part of the object with a different scale. I I don't know why anyone would want to do that, but you can. And then literally in layout view, you can turn off those other ones so they don't show. So that's another thing that you can do here, where you can turn off the one-to-one, or turn it on so that it shows and doesn't show whatever size you use. But I don't know why one would want to do that. So I'm not focused too much on that.
Okay.
Because all of our dimensions should be about the same size, right?
Yeah, and then
Yeah, there's no reason to do that. Although, like if you're zooming in, let's say you were zooming in as part, you might have a different one. It would make sense. Yeah. Okay, go ahead. What was your next question?
Joanne has talked about before when we were doing our manual drafting, in between, say, the front and top view, she would want us to annotate the overall width because that is the same dimension in both. Do we do that in AutoCAD, or would we be dimensioning that width on both the top view and the front view, even though it's the same?
I think you need to go back to Joanne. She's going to be grading these drawings, but in my point of view, there's two things. One, you're supposed to put dimensions between views rather than outside the view where possible.
Yes.
So is she mentioning that? Or is she actually saying in the top view, you put a dimension for the overall width, and then the front view, you put a dimension for the overall width? If that's what she's saying, I would say, I don't think that's what she's saying, because that's over dimensioning. We never add the same dimension to two views.
I think it was either or, as long as you had it.
Yes, that's what I'm trying to say, is it would be the overall width for the, you would just dimension the width once, but I don't see how you do that, like, because it's going to be coming off, say, my front view, but then you won't see it coming off of the top view. You'll just see that the top view edges line up with the front view edges.
That is the correct way to do it. That is right. And if you have aligned the two views correctly, you could literally, remember everybody that this was not meant to be solely electronic. You would print this and you would have a straight edge, and you could put a straight edge against the edge of the top and the front view and on both sides, and see that that dimension applies to both. Okay, so that is the correct way to dimension. You need to dimension it in one of those views, not both. And if the views are aligned correctly, then that dimension would clearly apply to both views with a straight edge. And you could draw a construction line down if you wanted to in the electronic view and see that the edges are exactly lined up.
Right.
Right.
Okay.
Okay. All right. What are we talking about? Anything else we were talking about?
I had just a general question. So when we're converting this to electronic form, would we be going in the same settings as if we were like selecting a printer, but instead we'd like hit to there's like
print a PDF. You're going to print a PDF.
Okay.
Right? Let's double check that though. Print. I don't know what that is. Okay, let's see if PDF was here. Yes. So you're going to do, sorry, let me share. I wanted to double check that it was there before I shared. But when you go to your print screen menu, see here, you can do Adobe PDF.
Okay, perfect.
Okay? And make sure that the page size comes up correctly. Otherwise, you can adjust that under properties. Actually, right here, letter size. Oh, what did I do? I did something I didn't want to do here, right?
Right.
It should be letter, so that way it's 8.5 by 11. Okay.
And it would be letter, not ANSI A? Or does it not matter?
Actually, it's the same.
They're the same.
Right.
Okay, okay. Gotcha.
They're the same. It just depends on what your preference is, right?
Okay, for sure.
Yeah. And I don't know what you're working in. Are you working in inches or millimeters?
I personally am working in inches. I don't know if other people are working in metric.
Yeah, so if you're working in inches, just go with your inches format. If you're working in metric, go with the metric paper layout format. It's all the same, right?
Yeah.
They're just different naming conventions, but it's for the same size. Yeah, so that's how you would do that. And then when you print, oh, you know what? When you print, let's do, okay, learn about batch plot. Notice you have multiple drawings, batch plot for multiple sheets at once. What do you want to do? So we want to batch plot because you're going to have multiple layouts down here, right? And we're going to do that to PDF. So it will create a PDF of all your different pages. Okay.
Gotcha.
So that's what you want to do. So it'll create a book. You want to? No, I don't want to do that. What I wanted to show you is everything you're doing is a model. We go to layout to set up our prints, and you can add up every layout. So here, oh, and you can rename them. So if you right click on this, rename, let's just say your first one is your assembly drawing. Okay. The second one, right click on this, rename. Let's call this sub, I don't know, assembly one. Okay, so you can have all your tabs renamed, and then you go to layout, a new layout. See, that's the generic window that pops up. Delete that because that's probably not what you're going to use. And then you can rename this as I don't know. You could give it your actual part name, but detail number one. So you can have a full. You can keep adding pages here and have a full set of drawings you've put together, and then you can batch plot so that they all come together in one bullet. Now, when you guys are doing this, please, please, please remember to save. Okay, so you see my asterisks. I have not saved in a very long time, and if this crashes, I lose everything. So make sure that you're saving often, because as you say you have 20 tabs down here, that's going to start using a lot of memory. Okay.
I have another question about layout.
Yeah.
When you're in layout and we want to get our edges perfectly lined up so that the dimension of the width we can see is the same for the front view and the top view, how do you do that? I have object snap parallel on, but it doesn't, my object snap doesn't seem to be helping me at all in layout.
Well, parallel isn't really going to help you at all. Let me see. I don't think I have objects. I didn't have it on at all anyways. I think possibly that and ortho mode will help me. So let's go here and let's click in here. And I don't know that it's going to work actually. Let me just see here. I picked the wrong object snap. Yeah, I can't get between views here. That's a really good question because I don't normally create viewports like this. So how do we get them to align perfectly?
Should we align top and bottom and then maybe do like 3 viewports so that we have one viewport on the left-hand side that has top and bottom?
You could definitely do that for sure. There you have, and you could also do the polygon one where you get all 3 of them aligned in model space. You get all 3 of them in one view. You could definitely do that. Yeah.
So
it just allows you to control each viewport, but you don't have to do it that way. You're right. All right, so let's go here and let's do that really quick. Layout and object polygon. Okay, so let's specify the start point. Oops, now I'm in ortho mode. Say here, say here, say here. And I should have inserted my border and everything first, obviously, so that I'm working in the right space, but here, okay. And hit enter. All right, so here's my, oops, 3 views. Imagine 3 views came through, right?
Yeah.
This is definitely a possibility.
Okay. So you did base. What you went to layout viewports? No, you went.
Layout, and I did the drop down here on polygon, and I drew the shape of what I wanted my viewport to look like. My viewport, my one viewport to look like.
Okay.
Yeah, definitely. That is a good option, actually. Right, and you can adjust this if it doesn't look the way you want. You can always adjust it. We clicked in here. Clicked in here for some. There we go.
How do you get rid of the quadrant then? Viewport. You just go to view.
Which quadrant?
If I was in not on your screen, but if I was in the 4 equals,
Ah,
do I just go back to single?
how do you get rid of all this?
Yeah.
So one, you could delete them individually, which I think you have to actually. If you wanted to get rid of them, you just double click on it till you get the blue, right? Oops, you don't want to do that. You just want to double click on it once till you get the blue. I double click many times, and then you could just delete it. Once you've got it highlighted with the blue, you can delete it. So it is a bit tricky to get onto that, to find that blue click. I don't know why. Oh, lovely. I'm moving. So that's why you would lock it. Do you see how I was trying to get on the blue and it just did that? Of course I can hit Control Z. It brings it back. But the point is that's why you might want to lock it. So I'm having a hard time clicking, but I did get it. It's the one problem is getting it on the blue. It takes some accurate clicking with your mouse. There it is. And then once you get it like that, you can hit delete. Okay.
Okay. Is there any way to clear of? Oh my God! What just happened? Ah.
And then once you get in that mode, it's easy to click on blue again. Everything is blue when I click on it, so I can delete them all. Go ahead. Is there any way to what?
Well, I don't know. I was trying to click the blue and it freaked out.
Yeah, it did that for me too. So just click model and then come back. And you'll be fine. One thing I didn't mention, which is interesting, is that you can divide a viewport into other viewports. So let's say I have this one. I can type viewport to get the menu. And I can say, I want this one viewport to be in 4 equal ones. Let me see. Let me just double check. It should be 4 equal new viewports. This isn't doing it. Set up. Let's see, it's probably going to put 4. Yeah, it is going to put 4. There's a way to actually divide an existing viewport into more viewports, and I thought that was it. I don't know why it didn't work for me. Double check. That's not what I want. So it did the same thing where it kicked me out, and then I just kind of click away to get back. And then the other thing is, if you want to get out of what you've clicked on, click in the white space and it gets away from that. So, working with viewports is not easy, but it is the proper way to print. And I know that in the future semesters, you go to 3D modeling. If you create a 3D model, then actually AutoCAD is really adept at creating your top, front, and right side view from your 3D model perfectly aligned and allowing you to add dimensions to your viewport in Paperspace. So that's the way I would normally do this, but I think we don't learn 3D in this class, so that's why we're not doing it that way.
Okay. I just tried to make the polygon, and my tools to be able to, was it pan to move sideways? Those disappeared. I don't have those, so I can't move my image at all, which is very frustrating.
Well, I use my roller ball to pan like this.
Oh.
You have a roller ball that you can push on?
No, I'm on a laptop.
Where were the tools? Were inside of here, right? When you
Yeah, they
double-click
were, but they
right
disappeared.
there. No, right here. Pan. This one?
Yeah. How did you get to that? I guess
Well,
I type it in, but because the tools aren't appearing anymore.
well, first of all, make sure that so again, click on the white, get out of everything. So I'm out of everything. And then I can click inside the box and the tool pops up.
Yeah, it's not popping up.
I'm not sure, but you could type it into the command line, or you could hit Control Z to undo whatever got rid of that and try it again.
Okay.
Okay, so, we haven't taken a break. It's 4 o'clock. I think we should take a break. While we're taking a break, you guys should play around with the file, creating viewports, going to your layout tab after the break, but you should at least upload the file if you haven't. And then the rest of the time is for you to work on your drawings for class and try to get them into the proper layout. I would really love it if people were willing to share their screens on anything you've drawn so we can talk about that and learn from each other. But it's already 4 o'clock, so let's take a break until 4:15, and then we'll come back together and see where we're at. Thank you all for signing in. I did get you. If I said hello to you directly, I noted you were here. Are we back? Thumbs up. Hello? Okay. I have 3, 4 folks here. 5, 6. Great. Okay, great. Thank you. Thank you for letting me know you're here. I appreciate that. So one more thing I wanted to show you on the viewports that may address a question we had earlier from Gillian. So I'm going to share my screen. Oops. Open AutoCAD. All right. And hopefully you're all seeing this. This is again our still end layout. And what I've done is there's also the view tab up here. So until you get to one of the layout tabs here, you won't get the layout menu. But before then in model space, there is the view tab. And in this area, you can create a top view, a front view, a right view, an isometric view, creating little windows of what you've made in model space that you can insert into your layout view. So what you would do first is click new view. And I already created a top one, so I'm just going to say front. And I'm going to say define the window, which is going to allow me to select space. That is the whole front view. I can adjust that if I want to, but that's the only thing that will appear. So this is addressing also keeping your things spread apart. This is the only thing, whatever's in the black window you see is all that will appear when I insert that view. So hit enter to accept. And I think I just hit okay. I just want to double check what's here. The category, I haven't created categories. Type, this is fine. Hit okay. Now, when I go to layout, and I can now have the layout tabs. I go here to the layout tab. I can go to insert view. I mentioned I'd already created the top one. I just created the view called front, and I can insert that. You know what? If I had my grid on, it would be really useful, but let's just put that there. Insert top. So my top window, I clearly made bigger than my other one. You can see nothing else is in there. I've created a space with just that view in there. And when I double click in it, let's try and double click in it. Oh, it's locked. Okay, let me unlock it. We'll click it. Okay. It's still all there, but I was able to capture it from the model space just using without playing around in this area here, trying to make a polygon or whatever, just by collecting those views. And actually these are scaled the same, they're just not lined up. So I would just have to figure out a way to line them up. Or if I created the same size windows in model space, they would have been naturally lined up. So I'm not sure if that's helpful or not, but I thought I would share that as another option for creating our viewports. And this one's locked too. All right. Any questions on that? Okay. So I'd love to answer your questions if you have any. So I guess I'm waiting to hear on what your questions are.
This is more just like a confirmation kind of thing. So like when we're making our isometrics, it doesn't have to be perfectly to scale like with our multi-views. Because I'm trying to make it look, like you're looking at it from a
What are you
30-degree
making?
angle.
Just out of curiosity, Ben.
Well, the whole project is for a table, but what I'm making is like a table. It's like a circular table with like kind of a lazy Susan kind of deal. So
Okay.
it's like multiple like kind of layers that kind of just fit on top of each other.
Have you changed your cursor to be an isometric drawing?
Yes.
Okay, so then, and you're doing isocircle.
Yeah.
Couldn't you insert the right dimension on isocircle?
Yes.
Okay, so
Yeah,
then if you,
oh, sorry.
no, so if you create, so then it is to scale, I would say.
Right. Well, I'm just thinking because I'm making it like, I like put like an arc under the circle to kind of make it look like more like, like 3D, even though it's in a 2D space, just to kind of fill out that kind of.
But why don't you offset your circle down? And then connect some lines on the edges and delete the extra lines.
Okay, yeah, that sounds like a good idea.
Yeah, let's do that. So just
Okay.
make sure you offset in ortho mode and you go down the depth of your top. I don't know what that, whatever the thickness,
Right.
and then you'll see naturally on the edges where you would draw a line down and that creates your depth.
Okay, yeah, that sounds like a good idea. Thank you.
Okay, yeah, you're welcome. Other questions? Okay. So then what we'll do is we're going to hang out together, and every time you have a question, I will start the recording so we can record those questions. And I will pause it in the meantime. Before I do that, sorry, one last thing. So next week's module goes over how to make isometrics, I believe. I'm double checking that because I thought I put that in there. Yeah. Drawing isometrics in AutoCAD and some other tools that are available, the measurement commands. We do not have class next Wednesday. So I have posted these videos. I've said they're required to watch so that you know how to create your isometric and add dimensions if needed to it. And I will see you the following Wednesday. Now, I do have an AutoCAD homework 5. Let me double check if we're going to get rid of that because really we want you to be working on your drawings. So let me, AutoCAD homework number 6. So let me double check what AutoCAD homework number 6. So AutoCAD homework number 6 is to create 3 orthographic views and a isometric of the objects I've given you. I think we'll leave that alone. I think it's really good practice. So you may want to actually work on AutoCAD homework number 6, practice for your table view, your project drawings, because it will help you in a simplified way to reach your goal on your project drawings. So it's actually a useful exercise.
So we do have homework this week?
Not this week. It's due in 2 weeks.
Okay.
So it's not due the Sunday before Thanksgiving, but the Monday before Thanksgiving, but the Monday after Thanksgiving. And it's really good practice on everything we've gone over with dimensioning and then next week's orthographic views. But this week, the focus is really starting to get your drawings together. Let me double check that I have the date right on the due date and everything. No, I don't. So I'm gonna make sure I update that. Any questions on any of that? Okay. Okay. So the dimensions are actually the right size. Can you zoom in on the page? Yeah. Oh, sorry, not in the window. Control Z what you did.
Here, I'll just go back and set the scale.
Yeah, go back and set your scale properly.
Okay.
All right, now click outside of your window.
Okay.
Maybe in the white space on the page, not in the window. Like double click there. There you go. Now zoom the whole page a little bit for me. See, they are actually a good size relative to the object.
Okay.
What size did you set them at?
0.125.
Okay, so they're 1/8 of an inch.
Yeah.
Yeah, it should be fine. I think just when you're zoomed out like this, trying to fit the whole page on one screen, it's not easy to see, but it should actually be fine.
Okay. And then
Did you do a print preview of this?
Plot preview?
Sure.
No plot.
Oh, no plotter is assigned. You need to just go to print and then the top one is print. Oh, continue to plot single sheet. Just do that one. And then you need to set it. Remember, I said that you need to pick PDF or printer to do preview. You need to set something. If you have a printer, you could set your printer, something, and now you can do a preview at the bottom left. So do you see that you can see some of those dimensions very clearly?
Yes.
So they are fine.
Okay.
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 You could change your scale a little bit because what you've drawn is a little tiny. So you could increase it if you wanted your scale.
Yeah, I'm just wondering, Joanne made it very clear to us that with scales, we can only have a 2, a 4, a 6. There's specific scaling.
Oh, she gave you? Okay, well then you're
I think, I mean, she didn't give it specific to our project, but she taught us, when she taught us, she said that when we're doing scales, and somebody else can tell me I'm wrong, because she didn't actually specify this, but we did learn when we did manual drafting with her that we can only have like 1, 2, 3, 4, 5, or 6 as the first digit in our scale, and everything after that has to be zeros.
I think we did only those factors for scaling because those were the only ones we could use on our physical scale ruler.
Yeah.
I think if it's digital, we have more freedom.
So
and I was gonna say, when you said 1, 2, 3, 4, 5, 6, I was thinking that's the engineering scale. That's the sides of the engineering scale, right?
Okay, so you think we can use any scale that we...
You should be able to use any scale necessary for your project. Every one of you is going to have a different scale. Those of you building a huge workbench are going to have a different scale than you if you're building a bird feeder,
Yeah. Okay.
right? You can't limit yourself to those scales. And in digital format, you have a lot of options, as Adam mentioned. So I'm going to say that you can use a scale not, and when you put the number 1, 2, 3, 4, 5, 6 on the left side, that's enlargement. Definitely we're putting it on the right side, which is reduction. So keep that in mind.
How do I
Okay.
get out of here? Do I just
Just escape, hit the escape button
okay.
on your back and then cancel, or apply to layout and cancel. Okay,
Oh, save as PDF.
that's fine, cancel. There you go.
Lovely.
Okay, so really, can I just point out some things to everybody on this? Really nice isometric. She can, and she has her 3 views. They are correctly dimensioned. What else can I say about this? It would be great if you could add in your border and your title block. There are no tolerances, I will say, on your dimensions. So either you have a standard tolerance table or you need to add those in. And it would be great if you could do your border and title block so that you could have a finished drawing.
Yeah, I am having an issue right now. You can't see it on your screen, but on my computer, it just told me that it's asking me to sign into Adobe, and now it's asking for a serial number. And if I try to close Adobe, it wants me to quit, which I don't know if it's going to save my work. I don't know. Adobe has to do with AutoCAD. Is that?
Adobe, the print to Adobe is a part of AutoCAD. Can you, so can you go to Zoom and share your entire screen as opposed to just this window?
Yeah, let me try.
So you have to stop share with what you're doing and then share your entire screen.
It won't let me leave the page. It will not let me click out of the pop-up that says, if you have a serial number for Adobe Acrobat, you will need to download and install a different Acrobat file.
I think that's the PDF viewer.
So can I just close it? Can I just?
Yeah, that's for like viewing PDF. That's nothing to do with AutoCAD, I think.
Okay, I'm gonna say quit and hope all my work. Okay, we're fine.
Why don't you just do a quick Control S, please? Because you have a lot of asterisks across the top.
I did Control S. Does it?
That saved your stretcher short, but not the other pieces. So why don't we just save everything? Save all. See that thing? Save all. Let's do save all.
Where's that?
I don't know. You just had the window there when you clicked on one of the tabs at the top. I'll right click. No, maybe it was not a right click. Maybe it was a left click on, well, now that's saved.
Yeah, I was just going.
Yeah. And you don't need the border and model space. So the other thing I'm seeing is that you have all your different pieces in different AutoCAD drawing files, but you could create them all in one file.
I know, I didn't know that though, because we didn't have instruction before I started this. So now I'm just gonna have to go to every single different one and create a.
Well, so one thing about that is that it won't batch plot them all together.
Yeah, I realized when you were talking about that, I was like, okay, I'm not gonna be able to use batch plot. I'm gonna have to go to each separate file and download it as a PDF and then import them.
And
Yeah.
will you then be able to compile them all into one submission PDF?
Well, we're still, even if we did batch plot, we still have to compile them into the submission with our document that's saved as a PDF. So we talked a little bit about that with Joanne on how to insert PDFs into one another.
Okay, just making sure you all have the right software to do that.
I don't know. This all just seems very daunting at the moment. It seems like this is going to take hours and hours and hours of my time. Like doing each.
I don't know what to say about that, but the more complex your final project is, the more drawings that you need. But let me also say that you have a lot of drawings here, and as much as you can, try and utilize your drawings for each other. So, you know, stretcher long, stretcher short, try and just draw one and then copy it and then extend it out, right? To make it long, like try and, try to duplicate things where you can. And that's advice for all of you. You know, try not to draw everything from scratch is what I'm trying to say. Okay, try to use what you've already drawn and just modify it.
Okay.
By
So,
copying and pasting it.
I was having trouble. I know Steve raised his hand.
Oh,
and
sorry, I didn't see that. Okay.
I'll try to insert the border again, but I was having trouble with the one that you linked on the A size paper border that you linked. I still am not good at inserting stuff from the internet.
Well, first of all, you need to download that. Did you download it?
Yes, I did. It's downloaded.
Okay, so then let's go to the insert blocks at the top. Home or insert, either one of those tabs will work. Insert right there all the way to the left. Yep, that one. Click on it. Blocks from other drawings, I guess. All right, and then the three dots on the menu that popped up, those three little dots. And where is it? Let's go to downloads. It's probably in downloads. Yeah, that drop down at the top. Take it to downloads. How about clicking on OneDrive on the left? Okay. Oh. Ah, there we go. Documents, downloads. See that? I don't think you've saved it on here yet, unless you saved it somewhere else.
Okay, I'll go try. I did download it because I downloaded 2 different ones, but I don't know where it saved it.
Try your desktop, maybe. Sometimes it saves to desktop. It's definitely not here. No.
Okay, what? I'll go look.
Okay, so we'll need to get that on to a place where we can find it. Do you want to ask your question, Steve?
Yes, mine was very much related to what she was asking. If you put all your drawings in one file, so you'll have the front, side, and right views a certain distance apart for each one. Is there any convention about how all 6 drawings should be placed? In my case, it's 6 or 7. Should be spaced so that they don't have to be moved around again to put them on the final layout. Maybe it doesn't matter because of the way layouts are flexible or something.
Yeah, the layout's pretty flexible, so I'm not so sure that it matters. But if you wanted to do a polygon like Gillian had done, then what you need to do is, first of all, determine the amount of space that's remaining for the 4 viewports after you put in your title block and border. And then divide that space into 4 quadrants and then space them out accordingly so that they would be in those 3 quadrants there.
Well, then you're only going to put the title block once for all 6 drawings in order to import it into the others.
You're going to have to do it every time for every layout page.
3 times. Oh, for the layout page, but not for...
You don't put the title block in model space, you put it in layout.
Oh, okay. Yeah, thank you.
Yes, so you're going to, every layout, every plus that you click on the bottom and create a new layout page, a new paper space, you insert your border and your title block first.
Okay, thank you.
Okay, so don't put the title block in model space.
Yeah.
And then the spacing really just depends on the size of the objects you're talking about. It's not one standard format for everybody.
Sure, but then the isometrics will also, so...
Yeah, and then you put the isometric in that 4th quadrant, upper right quadrant. That's right.
Yeah. Oh, yeah, it probably doesn't matter, and they can be moved around pretty easily if it doesn't work out.
Yeah, and it could be moved around if it doesn't work out. That's exactly right.
Thanks.
Yeah. All right, other questions? Oh, but you've picked the one with no letters or letters or numbers, or is it? I think you've picked the one with no letters or numbers and just arrows.
Okay, so now I'm struggling to be able to delete it because there's overlapping lines.
There it
go.
is. There, and now
Okay.
you can delete it. Yeah, so that's not the one we want to insert, perhaps, if you want the letter.
I found where they were though. That's not what I'm looking for.
It is though, insert blocks from libraries. There you go. Ah, all right, do the 8.5 by 11 for class. That's the one I used. The next one over right. Oh no, wait, what's the one to the left of that? Yeah, try that one. Is that the one you used?
No.
Try that one.
Oh, you can't see it till I insert it. Interesting. Okay.
There you go. It's there. Just hit
to
enter.
line it up though.
Well, so it's the thing is it needs to be inside that dotted line.
Inside?
So you won't be able to line it up perfectly. You're gonna have to scale it because everything outside of the dotted line is not printable area.
Okay, so how do I scale?
With the word scale after you, oh, well, you could scale it now. You could click in your command line on the scale button.
Oh, scale, okay.
And then enter a value.
But I don't know what to enter.
Yeah.
So how do I do it?
Well, is it going to be bigger or smaller than what you're entering? I mean, what you're inserting?
Smaller.
Okay, so try a number. What'd you put in? We didn't see.
Oh, 0.5.
Okay, I'll go ahead. See how small that is? Is that what you want?
No.
No, so hit scale again.
Okay, so
Try.
0.85.
You can try moving it around and seeing if that's a good size. Looks not quite right. Yeah, so there you go. You're playing around with the scale. That's looking better.
It won't, I can't drop it. I'm having trouble inserting it. It won't.
Well, you just have to click inside on your document. You have to just put it. That's why I said just put it in there and worrying about moving it and scaling it later. So you just have to click. The problem is you're probably trying to click where those lines are for the command line. It looks like it got stuck in there actually. So yeah, so close this menu, the X. Now you can manipulate it however you want, because now you can move it, select the correct base point that you want to use to do that, and you can scale it with that. Because it was coming in with a base point that probably wasn't very useful. See the base point? It's in the bottom left there.
Yeah.
So that's why drop it in and then adjust it as needed and select your base point for scaling and for moving.
Okay, and so once I have this border, am I gonna want to change these?
Yep.
Yeah.
That's why
inside.
Yep, that's why I said the first step is insert your border, get it right, then attach your title block, get that right, and then create your viewports and everything.
Okay.
Yep.
Okay.
Yep. Okay, hopefully everybody else saw that so they also understand what's happening. Any questions? No, it's okay. Go ahead.
So I'm making sort of like a box, basically is what it is. And the thickness of that box is always going to be 0.25
inches.
So the front views for most of the panels, so like the right panel, the left panel, the top and the bottom, are all pretty much going to look exactly the same. The only difference is that the top and the bottom are going to have like, so I'm making a container that's going to hold hats but it's going to hold them perpendicular rather than having the front of every hat being visible, like where you stack them and it's kind of like you can only see the front of the very first hat in the container. So I'm making it to where you could see like the side of every hat. That way you know what hat is in what container, right? And so I'm making the containers so that they're stackable. So the top and the bottom, when you have the front view of those panels, they're going to have like little hidden lines, or they're going to have like just a little pattern around so that they can click together. So if you produce multiple boxes, they can stack and sort of like stay together neatly. I guess the only issue I'm having is that because it's such a small, because I'm making it 1/4 of an inch thick, but most of the panels are 12 by 9 inches. So in comparison to like the top view, the front view is like super, super thin. It almost looks kind of like a line.
Yeah. So your question is, do you have to show that hidden line? The answer to that is yes.
Yeah, but like, okay, so my answer was mainly going to be for those hidden lines and stuff like that, because they're so small, how would I go about dimensioning them in a way where you don't have to like zoom in super far to like see exactly what?
Well, remember, you can put a note that says thickness is 1/4 inch.
For like the panels and stuff like that?
I thought you said every single one was 1/4 inch.
Yeah, no. So it's kind of hard to like explain myself because it's like, so I guess what I'm having trouble with right now is when I make those little grooves, they're going to be obviously less than 1/4 inch. I was probably thinking like, because they can't go all the way through the panel. Do you know what I mean by like a little, am I explaining myself right, or is it?
I am envisioning a 12-inch by 9-inch box that is hollow on one end, that is 1/4 inch thick. If that's not what you're making, I don't know.
I would share my screen, but like AutoCAD kind of crashes when I do that, like when I'm on Zoom, so I'm on my tablet.
Okay.
I guess this is something I guess I'm just gonna have to try to figure out. I'm not quite there yet. I'm just asking for like when I get there. But
I the only thing I'm understanding is that it's such a large object, and by comparison, it's very thin. It's a very large, thin object.
yeah, so think of like a sheet of paper.
Uh-huh.
And that's like one panel of my box, right? So I'm focusing on just one panel right now.
And how many panels are in your box? Are there 5?
So picture like a sheet of paper. It's 9 by 12, but then the thickness of that sheet of paper is 0.25 inches. So when I'm drawing my views, obviously like my top view is going to be a 12 by 9 box, and then my right side and my front view are just going to be either 9 by 25s or 12 by 0.25. So they're going to be like super thin, like almost lines. And I guess that's not really an issue because I can dimension them and then like sort of put a note. What I'm kind of having trouble with is when I do go over to that front view, obviously there's going to be hidden lines because there's going to be a design sort of like carved into the panel that's not going to go all the way through. So it's going to be less than 0.25 of an inch. So when I'm dimensioning those things, when I go to dimension them, it's going to be super small.
But do you remember I showed you that little round window that you can make? That's a call out where you can zoom in to a corner of your box.
Oh, okay. So I should probably do that for my.
Yeah, you should probably zoom in ultra big into that corner of your box to show the thickness and whatever else is happening that is so small that can't be shown in the normal size.
Okay.
Yeah, I would do a little call out, a round call out. So on your normal scale, you might put a phantom line circle with an arrow over to the enlarged section where you can show those dimensions larger.
Okay.
Does that make sense?
Yeah, that makes a lot of sense. I don't know why I didn't do that. But...
Okay, no, that's okay. That's what we're here for, right? That's why we're
Yeah.
talking about it. And you may not be the only one with something so large that you need to zoom in on a specific area in order to show the true dimensions. So that's could apply to more than one person in the class. So it's good you brought it up.
Thank you. I think that's
Yeah.
probably the only concern I had right now.
Okay. I think Tony has her hand up. Do you have a question?
Yeah, I'm just wondering if you can repeat what you said about the scale. So if the drawing is 1:1, and then you set the scale on the layout differently, then the actual scale would be what you said on the layout.
That's right.
Sweet. All right. Thank you so much.
You're welcome. Oh, someone else has a hand raised. Steve? Do you have your hand raised?
I can't unmute. Oh, okay. It took a while to unmute because I have two mice on the same time. I think mine is related to the second to last question, which is I have, objects that are about 17 inches long, but the thickness is only 1/8 of an inch. So I'd have to zoom way in to see the dimensions.
Right.
What was the name of the tape or the recording that you said where you give a lecture on that call out or something?
Oh, I did. I don't think I just showed you that
Oh,
in
okay.
class today. That
I'll
you can
review.
create a call out. So, like here, oops, sorry. Share screen, everything. Share. So in one of these layouts, where did oh, maybe I deleted it. Oh no, right here. See here?
Yes.
Okay, so
yeah.
so I've zoomed in on this area of it, right? And I could zoom in even more, right? To show more of that. So that's what I was indicating, is that you can take maybe this is like you can't see the thickness, but if you take a little section of it and zoom in in a circle like this, this is a very common way of zooming in on things. You could go into that finer detail and show that dimension of the thickness.
Okay, and do those callouts show the magnification factor, or that's just something you can easily see?
They don't. You're right. So that I was hoping someone would ask that. So everything down here on scale is going to be relative to these normal orthographic views. Something like this, you would put a note in that says, enlarged 10 times or something like that.
Okay.
You could put a text in. So you can go to home and add text in any window right here. See?
Yeah.
Yeah. So you could add text right there, and that says what your enlargement scale is on that.
Thank you.
You're welcome. And I can move this viewport right over here into another, on top of another viewport, and I could draw an arrow as well that shows the enlargement. So that's how you could actually call it out. You can also make it bigger or smaller, so if it's too big, make it like that, right? And then zoom in to the area you want to show and just draw a leader line up to this arrow, up to this viewport. So that may work for some of you, some of you may find that very useful to get into those smaller dimensions. And I just want to remind you all about that survey too. Please don't forget to fill that out. It's just about how you're using AutoCAD and what works, what doesn't work, kind of thing. Other questions? Okay. So if there aren't any right now, I'm just going to pause the recording. Go ahead. Go ahead.
Okay, so the box I'm designing has like a little, it has like a door basically, but think of like a garage door. except you like kind of swing it out rather than like going straight up.
Mhm.
Anyway, it has to hinge to the right side and the left side of my door. So the right panel and the left panel of the like box that I'm making is basically just a reflection of itself. But I still draw two completely different drawings for each side
Mm.
because the top and right side view are going to be different.
Well, so you have two doors, right? One on the right, one on the left. Is that correct?
There, I have one door, but it has to hinge to both sides of the box, so the right and the left box. So it's gonna have like a track. Think of like a drawer. You know how it has tracks for like whatever it is, the drawer itself to travel along.
Mm-hmm.
So the right and the left are exactly the same. They're just reflections of themselves.
I don't understand how a hinge on the right and a hinge on the left would allow it to open.
So they're not really hinges, sorry. They're more
Okay.
like, what I meant by hinge was like, it's going to be attached to both sides, I guess.
I mean, is it like a lever on
No,
both sides? No.
it's not how to
Okay.
explain. So yeah, I guess, just think of like a drawer. You know how like,
A drawer has a rail on both sides.
yeah, and they're exactly the same, but you wouldn't be able to necessarily use the right side for the left side.
That is right.
'Cause-
You would not. So what you would do is make one in a drawing and do a mirror image of it, right?
Yeah,
Okay. And then you would create two detail drawings, and one would be drawer, comma, left, and the other one would be drawer, comma, right.
okay, so that would be considered two different parts then.
Yes, definitely. And the best thing to do is do one completely and literally just mirror the whole thing.
Okay,
So that's your easiest way to get the other, the other version of it, right?
yeah, so the only thing is like when I'm drawing the multi-views for them,
Yeah.
one of them is going to have hidden lines and one of them isn't, because the right side of one is going to be covering that rail and the right side of the other one is not going to be covering it.
I can't picture what you're saying, but hidden lines to solid lines is literally just moving them from the hidden line layer to the solid line layer.
Okay, so then I should
Same
just
drawing, mirror, and using your layers. Yeah.
Okay.
Does that make
Okay.
sense?
Yeah, I guess I was just confused as to whether or not I would treat them as two different parts, even though they're exactly the same.
Well, they aren't exactly the same from what I hear. They're one, like if we envision a drawer, the rail is on the outside of the right side of it at the bottom on one side, and on the left
Yeah.
side of it on the bottom on the other. That's not the same.
Okay.
Okay. They need to be, if they were the same, then there would be a problem. The drawer wouldn't work.
Yeah,
Right.
obviously.
So you have to create it different. So
Okay.
you have to create a drawing for your left side and your right side. They happen to be exactly the same almost. And if you do one all the way through, you can literally mirror it and get everything else.
Okay.
Right?
Yeah,
Okay.
that makes sense.
And then do a few more modifications, like moving some lines from hidden line to solid line layer, things like that.
Okay. So then I
Okay.
guess I'll just do one and then
And mirror it.
reflect
Yeah.
Yeah, just mirror it.
Just
Okay,
make
sounds
sure
good.
you finish one all the way through so that you don't have to keep mirroring. Everything's all done, right?
Okay. Yeah.
Okay.
Thank you.
Yeah. Are there any other questions right now? Okay, I'm going to pause. Okay. So first of all, I want to just point out that is not an isometric upper right. It's an oblique.
For the layout of this?
Move your cursor up to the upper right, whatever you've drawn, that's an oblique view of this object.
Oh yeah, I was just trying to figure out like the layout, how it would look on the layout and make sure that it fits. And then kind
But
of,
that's, I think you're, okay, so we want to draw an isometric. So this is, whatever this is, you have to redo that. Does that make sense? This is an
Yeah.
oblique view. Okay, so that you've taken the top off of that and put it over here on the left, right?
yeah,
Above your, but actually you need to delete that top view. Top view is going to be a rectangle, just like the bottom view. Sorry, the front view.
oh, that's right. See, that's what I'm saying. I knew
Okay.
like I knew it looked weird. I was just like, it's been so long. I was just like,
No, it's okay. So remember, when we look at it in 2D, those angled lines become straight lines, right?
mhm,
So that's what we want to remember. Does that make sense?
okie dokie. Yeah, for sure. Thank
Okay,
you.
you're welcome. So make sure though that you create the correct isometric. That's not an isometric, that's an oblique.
Yeah, I was just trying to set it up because I want to cut the wood and just have like sort of like what to go off, but I guess I can just do the actual thing rather than.
Don't waste your time making the oblique
Yeah.
drawing. That's what I'm trying
Yeah.
to say. Instead, make your 3 views, dimension them, use those to cut your wood. You can come back and do the
Yeah.
isometric later.
I don't
Okay.
know why that made sense to me. But thank you.
You're welcome. Okay. Other thoughts and questions with all of you?
Yeah, I actually had a question.
Okay.
You probably went over this, but I'll just double check.
Okay.
So I have like, I'm making a desk, so it's gonna be pretty big. And so when I like dimension my, like use the dimensioning, the text is like super small. So should I make it bigger?
Annotative. You should make it
Oh, right.
annotative. That's what
Right.
we talked about right at the beginning. Yeah, and set that size to to 1/8 of an inch at least.
Yeah.
Did you draw it in model space 1:1?
Yes.
You did?
Yeah.
So how big is it?
Well, the biggest piece, which is the first one I drew, is 2 feet by 3 feet.
Oh, okay. Okay.
So, but then yeah, I already have it as my text size is 1/8 of an inch. So then it was like microscopic.
It was microscopic. So let's make it annotative and see if that fixes the problem.
Okay.
And then there's that scale factor that you can contribute to the annotative dimensioning. So if it's still too small, you could scale it at that point, and then it would stick with that scaling.
Okay.
My concern is, so you didn't scale it in your model space, right?
No.
So it's
I don't.
24 inches by 36 inches, which is quite large.
Yeah.
So the annotative is going to work really well when you scale it down on your layout space, but it might not actually help you in your model space as much.
Gotcha. Okay.
Does that make sense?
Yeah.
So annotative is going to keep it that 1/8 of an inch in paper space, but
Right.
I don't think that it's going to make it noticeably visible in model space. But you don't need it to be visible in model space, actually.
Oh, okay.
You only need it to be visible in layout.
Yeah. Okay.
Does that make sense?
Yeah, that helps.
Okay.
Thank
Great.
you.
Yep. Other thoughts and questions? Okay, I'm gonna pause the recording.
Title.
Go ahead.
When we put in our scale into our title block, do we just record that decimal, or should it still be in terms of like 1, 2?
Yeah, it should be 1, 2. So you'll convert that to a 1, 2.
Convert the decimal to
1 colon whatever. Yeah.
1 colon something.
Yeah.
Okay, so maybe
Divide 1 by that decimal, and that's what's on the right side.
okay, just to the best approximation, like
Okay, so let's say that decimal was 0.5, right?
Yeah.
So if you divide 1 by 0.5, then you get a 2. So it's
Yeah.
1 colon 2, right?
Yeah.
So what's your decimal?
0.248644.
Okay, so divide 1 by that, what'd you get?
0.248.
So could you just change that to 0.25?
See, that's what I'm struggling with.
Is what?
Well, then I'd have to go to custom, and I'd have to go to add, and I'll put in 0.1 or 0.25, 0.25, and then paper units to drawing units.
Well, no, but I think 0.25 is one of the established ones. It's 1 to 4. So you don't have to do that. You just have to select 1 to 4.
Okay.
Does that work?
Yes.
So again, remember, if you divided 1 by 0.25, you'd have a 4 on that side. So
Okay.
it's already established as 1 to 4.
Okay.
And will that fit? Will that do what you want?
Yeah.
Okay, let's use that. That's better than
Yeah.
some random number.
Yeah.
Yeah, okay, good. Okay. Great.
1, 2, 4. All right. Well, then I'm gonna leave. Thank
Okay,
you.
you're welcome.
Bye.
Bye. All right, I think the rest of us are gonna say goodbye too. It's 5:30. So if there isn't any lingering questions, I will see you all in 2 weeks.
Okay, thanks for everything.
You're welcome. Have a
Bye.
good evening.
Have a great week.
Thank you. Bye.
Daniel.